Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi again, everyone. Today we will continue a little bit on the topic of convolutional neural networks. As you recall from the previous video, we have seen how to implement the convolutional neural network in the Google Colab environment using Python. So today I'm going to talk about doing the same thing but in MATLAB. So I'm using the MATLAB release 2022, which is the newest one in UTM. So you can, whenever you are in campus, you can use this MATLAB license. Okay, it will work only in the campus. Okay, the focus of today will be on how to use the deepNetworkDesigner. That's part of the tools provided in the new version of MATLAB, and you can see how easy it is to implement the convolutional neural network to solve the phase classification problem. And also a new topic that I would like to just briefly talk about is transfer learning. Okay, so transfer learning means you use a pre-trained network. So for example, you have LXNet, you have VGG16, you have GoogleNet. These are networks that other researchers have used, and they have trained using thousands of images. Okay, so the idea is we can just reuse their model.
I didn't understand that.
We can, so the idea is we can just reuse the model and just change some part of it to suit our data. Okay, so here I have open MATLAB in my computer. So to get you started with, you can refer to the help function in MATLAB. So you just type in transfer learning, okay, CNN, convolutional neural network, and there's a help document that can easily get you started off with transfer learning. Okay, so that's the document. So you can see here that the idea is you use a pre-trained network. Okay, so this is transfer learning. So we're going to use this method to solve the problem talked about in the previous video, lecture 8, right? Using the Python language. So now we're going to use MATLAB. So you can see here there are many available. Okay, this is the document. So let's just run the deepNetworkDesigner. So if you want to go to the details of my video here, is just based on the previous document that I've shown using the MATLAB help function. Okay, so you can type deepNetworkDesigner in the workspace, and you can see the tool. Okay, the deepNetworkDesigner is open here. So you can see a pre-trained network. There are a whole list of them: SqueezeNet, GoogleNet, ResNet, EfficientNet. So if you some of them you need to install them first. Okay, so I have installed. It's already SqueezeNet available, and I've also installed VGG16. So I'm just going to try VGG16 to solve our problem. All right. So once you have selected a pre-trained network, this is the screen that you will see. Okay, you will see this screen, and what you can do is you can zoom in into the boxes, so you can see the layers. Okay, the several different layers of this type of network, which is VGG16. You can zoom in and you can see each component of the VGG16 layers. So starting from the input layer and all the way to the output layer. So what we want to do is, as you recall from the previous video, we are working with the image of UTM students, right? The faces of the students. And if you recall, there are 7 classes. So let's load them into the Deep Network Designer tool. So you can load the data using this function. Okay, so you import the data first. So these are the 7. Okay, so here I'm using the color version. Okay, because the VGG16 works with RGB images. So what we have in the Python environment, we use the grayscale images. Okay, so now we're going to use the color version. Okay, so what I did was just to apply some color map and make it into a color image. Okay, I'm using the color map, hot color map, change it into a 3-dimensional matrix. Okay, not just 2-dimensional matrix anymore. So as you load the images, you can there are many parameters that you can apply. So when training, you may want to augment the images. So rotation, you may want to rotate it, you may want to rescale it. Okay, during training, right? So to improve the generalization ability of your model. And also in the validation part, you can choose how many percent of the data that you want to use for validate. Okay, so that means 70% will be used for training, 30% will be used for validation. So as if everything goes well, then you will see this. Okay, so those are the data. So we have 7 classes. Then the tools also give you the number of observation, and you can observe the different classes. So you can see that these are the exactly same image used in the video online lecture number 8, right? Okay, so what we want to do is we want to adjust this network to suit our problem. So first of all, the input, I'm going to just make sure that the input dimension is the same as the data that we have. Okay, so let's just change the setting of the input dimension. So what I'm going to do here is going to read a sample of the image and just check the size of the image. So we can use imRead function. You can see in the workspace the value is 132 times 101 times 3. So that's the dimension of our image. So I'm going to use that in our input in VGG16 network. So we can remove the previous block, input block, and change into the new one with input 132. Okay, it's going to be 132 1013. 3 specifies that the image is color, right? So you can remove the old one, and so that's how you change a layer. Just a simple add a block, delete a block, and you can click the block to edit the properties of the block. So the idea of transfer learning is you just change the final layer of you just find so you can see here the output is 1000, whereas in our case we just have 7 classes, so we just put 7 here. So the idea is we just find the last adaptive layer of the model, and you change that to suit your problem. Okay, So I'm not going to change all other parameters except the output size. So the output size changed from 1000 to 7 because initially there was 1000 classes for the VGG16. So I removed that final layer. So it's going to be suitable for our case now. So you have to remove the final layer, which is the classification layer. So you just remove, and the output will be set according to our output. Previously it was 1000, now it will be 7, right? And okay, so now let's analyze. Once you have finished that, and you can see if there's any error. So here we found one error because of the changes that we made. So sometimes you have to remove the previous block and just replace it with a new block. So it's FC16, sorry, FC6, yeah, FC6. So we can just get a fully connected layer, a new one, probably because we changed the input size and causing the error. If that's the case, you just change it to a new block. Okay, MATLAB will automatically adjust the input and output of the block. So I'm just going to, okay, this 10 and this 10 is following the guideline from the help document. You can read that. So output size of this, I'm going to make it the same as 4096. Okay. But the input will be auto, so probably that's the reason why it's not working. So let's remove the old one and use the new one. Should be okay now. So as you can see, it's just drag and drop, so you don't have to type your code. If you use this tool, it's much easier for you to toggle or improve your design. Okay, so now we don't have any more errors, so we can start the training. We can click the training tab. Okay, that's the data, so that's the data tab. So just 3 tabs: designer, data, and training tab. So we can use this tab to train. So I'm going to change some parameters, so you can use what kind of solver you want: Adam, gradient descent, and so on. So I'm just going to use a small learning rate, validation frequency 5. So mini batch size is 4 in our case because that's the smallest number of a particular class, okay, of observation for a particular class. So if we train, we can see what's going to happen. So once you click train, then the VGG16 model will be trained using our data. Okay, and it's going to be just focusing on replacing the final layer, okay, final layer of the existing model. Remember, it has been trained before using thousands of images, so hopefully it will work for our case. But of course, if we can find a model, pre-trained model that has been trained using human faces, that will be much better. If I recall, VGG16 is a model that has been trained using images that consist of many categories, objects, animals, and so on. So, but anyway, this is just a tutorial to show you how we can use this tool. So you can see this training has started, so you wait until it ends in the final epoch. So I'm going to speed the training process a little bit because it's going to take some time, if I'm not mistaken. Last time I tried, it's about 10 minutes, so I'm going to skip it. So you can see actually it took 34 minutes, 35 minutes, okay? But this is during the screen recording running in the background, so normally it doesn't take that long. Alright, so then you can see we got 50% accuracy, and you can export the result into your workspace. Okay, so it took half an hour using my laptop, but that is when the screen recording is running, so that's why it takes a long time. So then you got 50%, which is not bad. We haven't tuned anything, so you can test it. So you can see here you got set 1 correct. Okay, that's the picture for set number 1, by the way. Okay, the first student. You can try a different student. Let's see set number, let's say set 4. Okay, so set 4, let's just read into I. You can automate this process later. So let's see if we can classify this correctly. So once you press enter, I'm just trying to show you how we can classify the network. The network has been how we can classify the image. So now the image set for, so that's correct. Okay, 72.1% confidence. All right. So you can save your workspace. So you got yourself a BGG16 network that has been trained for your data. Okay, that's called transfer learning. Sometimes you want to get the code. Okay, you can also have more control if you use code. If you don't want to use the graphical tool, you can just use it once in the beginning, and then if you want to type your own code, you change the parameters by the traditional way of typing, right? So you just specify a location where you want the code to be, and you can see the MATLAB can generate the code for you. So this is going to be similar to the Python script seen in the previous video. So you can see from this file the code for the model has been saved by MATLAB. Okay, so you can see that. So that's how easy it is to design your own convolutional neural network using a transfer learning idea, right? So you don't have to redo everything, but you may want to design your own. Also, it's possible to use the tool, the deep network tool. Yeah, you can see that's the layers, right? Convolutional layer, max pooling layer. So you can adjust it manually here if you don't want to use the tool. So you can see that's the final layer with 7 classes. Okay, so you can edit this by typing it easily. Okay, so 50% accuracy. That's not too bad for a first try. So there's so many things that you can fine-tune further to improve the accuracy. Although, like I've mentioned in the previous video, the data set is very small. Okay, so probably that's one of the reasons why you won't get as a very good accuracy uh, because we just have too small number of data. Okay, everyone, I hope you have learned something for today. Thank you very much. See you again. Assalamualaikum warahmatullahi wabarakatuh. Bye bye.